A manufacturer wants to design an open box having a square base and a surface area of 108 square inches. What dimensions would the box be in order to produce a box with a maximum volume? Okay, so here's what we're trying to do. It's an optimization question, just like we did yesterday. What about this problem tells you that it's optimization? Maximum. Our job is to find a maximum volume. All right, so the ultimate equation that we're dealing with here is volume. I want to maximize that, just like we've been doing. If I'm trying to maximize volume, I need an equation for that, and we're going to work from there. The best thing to do here is to draw a picture of this. So break out your best 3D drawing skills, but draw a box. Okay, it's got a square base, and then you're going to try to draw some sides from there. We're drawing a box. Do the best you can. Here is a visual of what we're trying to do. So I'm holding up a box. But it's got a square base. We've got some side, and it's open topped. Everybody agree with what we're trying to draw here? So this has a square base. So if I'm looking at this thing, two of the sides on the bottom, like this side right here and that side right there are the same. What would you like to call those sides? X. So they're the same. So let's call them both X. If both of those sides are X, what do we want to call the height of this box? Let's call it Y. You can do other weird letters if that makes you happy inside, but X and Y make the most sense. So we've got X and Y. So I want to write an equation for the volume of this box using that picture right there. How do I find the volume of a box? Length times width times height. And on this case right here, it's going to be x times y, or x squared y. X times y, the three sides multiplied together. That's my equation I'm trying to deal with. But the problem with that equation, if I want to maximize this, it's written in two letters. I've got x and y. I don't want x and y. I want them all in terms of the same thing. And so what I need to do next is I need to find another bit of information to help me out. Here it says the surface area is 108 square inches. So that's what I'm going to use here. I'm going to write an equation about surface area. 108 is equal to the surface area of that box. Take a second with your neighbor and come up with an equation for surface area.
What about the bottom?
I need an equation that tells me surface area of this. Think about it and break it down into some different concepts here. If I'm finding the surface area of the bottom of the box, what is the surface area of the bottom of this box going to be? X squared, because it's length times width. The base is both x and x, so it's x squared. It's not 2x squared. It'd be 2x squared if it were closed on top. It's not closed on top, so I only have one of those. And then you're looking at the sides of the box. What am I going to do to find the sides of the box? X, the base, times the height, and the height is y. So x times y, how many of those x times y's am I going to have? So it's plus 4xy. That is my surface area. X squared is the base, xy are the sides of the box. Great. I've got this. I want to plug it into my other equation because I want it to just have one letter. So I need to do some simplifying here. Let's take this equation over here and let's get y by itself. Okay. Earlier they said, hey, let's get x squared by itself because then I could substitute, but you can't get it by itself because you got an x right there too. So it doesn't really help us. Let's get y by itself. So if I'm doing that, I'm subtracting x squared. I'm going to divide by 4x. So my y is going to be equal to 108 minus x squared divided by 4x. Let's simplify that a little bit. 108 divided by 4, that's 27 over x minus, and then I'm taking x squared divided by 4x. That would be x over 4, or 1/4 x. I just simplified. That's all I did. Everybody good to that point? This is y. All we did is we got y by itself. We now know what y is. So what we're going to do is we're going to take what y is, and we are substituting it back in for y. Volume equals x squared times 27 over x minus 1/4 x. Now what should I do? Distribute. Let's clean that up a little bit because right now it's kind of ugly. So we're going to distribute. Volume equals 27 over x times x squared. Just 27x. And then x squared times 1/4 x would get me 1/4 x cubed. That is volume. That was the whole purpose of optimization. We have an equation. What are we trying to find? Volume. We're maximizing it. We've now got an equation for volume, and we've got it in terms of one letter. Everything's in terms of x, and that's what I was trying to get to. Now that I have an equation written in one letter, I can do optimization. I'm going to find maximums. I take the derivative. I set it equal to 0. I solve. I test it on a number line and figure out where my maximums and minimums happen. Everybody understand what to do from here? Try it with your neighbor. Here we go. We've got our volume equation. We're trying to find maximums and minimums. So if I want to do that, Logan, what am I going to do next? I've got volume. I'm trying to find max and mins. What am I going to do next? Find the derivative. So v prime. What's the derivative of 27x? 27 minus 3/4 x squared. That's his derivative. He's taking it equal to 0 and solving. So he's subtracting 27. And then I'm going to get rid of negative 3/4. So I'm going to multiply both sides by negative 4/3. It's kind of ugly, but x squared is 36. If x squared is 36, what's my x going to be? Plus or minus 6. Does it make any sense to have a negative side of a box? No. In fact, we're going to say that my box has to be non-negative. It's got to be 0 or above because it's stupid to have a negative box side. You can't do that. It's a black hole. Okay, so 0 and 6 are going to be my two numbers. We're going to pick a number between 0 and 6. Remember, this is a v prime number line. We're trying to find when volume changes signs. So a number less than 6, like 1. I'm going to take 1 and plug it into my derivative. If you plug in 1 here, 27 minus 3/4. Oh, yeah, that's going to be positive. A number bigger than 6, like 10 billion. Oh, yeah, that's definitely going to be negative. 6 is a maximum like we thought it was going to be. And so let's answer the questions. What dimensions should the box be? Well, x should be 6. That means my other x should also be 6. And my y value is going to be, how could I find that? Plug it back in. We've got a surface area equation right here. You can do that. X squared, so that'd be 6 squared, subtract it over, divide by 4 times 6. Your y value should be 3. Y is 3. Plug it back in and solve. 6 by 6 by 3, that's what my box should be in the end. Questions on that thing? That's pretty common. Make sure we can handle that. Let's try one more here. Or we might try 2 more. We'll see what time it looks like. A farmer wants to fence in 180,000 square feet of land in a rectangular plot and then divide it into 3 equal pieces. What is the least amount of fence needed to accomplish this? Farmer wants to fence in 180,000 square feet of land of a rectangular plot and then divide it into 3 equal pieces. So understand what you're doing. You have 180,000 square feet. You're trying to split it up eventually into 3 parts. And so when you need fencing, you need to have a fence at all of these at all of these spots. That's where your fencing needs to be. Talk with your neighbor. See if you can write the equation that you're trying to maximize or minimize, and try to write the equation of what other information is given. Let's see. We want to fence in 180,000 square feet, rectangular plot, divided in 3 pieces. Least amount of fence needed to accomplish this. As we read it, we're thinking, hey, this is an optimization question. What about this problem tells you it's optimization? I'm trying to find the least amount of fence. I'm trying to maximize or minimize something. All right? So my equation that I'm trying to maximize or minimize better talk about fence because I'm trying to maximize and minimize fence. So I just called it F. Okay? You could call it perimeter. I guess it's not technically perimeter because there's stuff in the middle too. But my fencing equation. Somebody got a good fencing equation for me here. Angela, what do you think? Okay, I'm good with that. You're good with that. I'm going to do it slightly different, but you're on the right path here. So she's calling this X. Oh, my bad. Yeah, you're right. You're right. My fault. 6X. She split them up into 6 equal parts. I'm just going to say X is the whole length of this thing, which is fine. It doesn't affect us in that capacity. Does that make sense here? It's going to make our life easier. So that's my X. So how many X's do I need to do if I'm doing fence? I need 2 X's plus my Y value. So boom, 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 boom. How many Y's do I need? 4. You can do what Angela said there. She said 6X plus 4Y. That works. I'm just going to get rid of a number because X is going to be that whole length of it. It just makes our numbers a little bit easier. So 2X plus 4Y, that's going to tell us the fence needed on this equation. Great, that's the fence needed. They better give me something else because right now I have 2 letters. They did here. They told me 180,000 square feet of land. So 180,000 is going to be equal to what here? X times Y. It's just a pretty easy equation. That's why I kind of did it the way I did. It's just the area. Well, to find area, I go length times height. Sorry. X times Y. And those in this case are the X and the Y here. X times Y. I can't speak. You know that. Don't act like that's the first time I've ever said anything stupid. I say something stupid every day. Oh, yeah, it's recorded. The people listening right now are totally weirded out by me all the time. It's cool. 180,000 equals X, Y. I want to use that here. What letter would you like to solve for? All right. You guys are weird and we're solving for X. So we're going to divide by Y. Divide by Y. That's my X. So I'm now going to take this guy right here and substitute it in for X. I substitute it in for X. F is going to be equal to 2 times 180,000 over Y plus 4Y. Simplify. F is equal to 360,000 Y over Y. I'm going to write it as Y to the negative 1 because we're getting ready to take a derivative and we don't really like fractions. Same thing, Y to the negative 1. Don't let that be weird to you. Plus 4Y. I just multiplied that 2 there. That's my fencing equation. Now that I have a fencing equation, I want to maximize, or in this case, minimize that because I'm finding the least amount of fencing needed. Okay? So if I'm going to minimize that, what do I need to do with F? Do that. Take your derivative. I took the derivative here, negative 360,000. Y to the negative 2 because I multiplied by negative 1 in front because my exponent was negative 1 and subtracted 1 to get negative 2. 4Y became just 4. Once we found the derivative, what am I doing with that thing? Set it equal to 0. And I know at times that can look daunting. This is a real easy concept. I don't like Y to a negative 2 and I'm trying to solve it. What could I do with everything in this problem to get rid of Y to the negative 2? I'm going to multiply everything in this problem by Y squared. Okay, think about what that does for us. If I multiply this by Y squared, this by Y squared, and this by Y squared, that's always a thing you can do in an equation. If you multiply everything by the same thing, you're good because you're multiplying everything by the same thing. What happens if I take negative 360,000 Y to the negative 2 and multiply by Y squared? The Y's cancel. It's just negative 360,000. I take 4 times Y squared. Okay, cool. It's 4Y squared. And if I take 0 times Y squared, okay, cool. It's still 0. You don't have to do that at this step. There were other things you could have done, but now this equation looks a lot less ugly without those negatives involved, negative exponents. Everybody good here? Finish that. You can do the rest from there. Finish it. I'm bad. Add 360, so 4y squared equals 360,000. Divide by 4, y squared equals 90. Square root, y is 300. Cool, that should be a minimum. Let's just double check ourselves really quickly. We definitely want to start at 0. I don't want a fence that is less than 0 feet. 300's on my number line. I'm plugging it into the derivative. It looks kind of weird because it's y to the negative 2, but just think about you're dividing by a number. Okay, so if you plugged in like 1, it'd be 4 plus negative 360,000. Yeah, that's negative. And if you plugged in a number bigger than 300, like 1,000, when you subtract this, it's going to be positive. If you don't believe me, plug it into your calculator. It gets kind of funky. Just plug in your calculator. Is 300 a minimum? Yeah, because f prime changes from negative to positive, and so that is a minimum. So 300 is what I want my y value to be. We're trying to find the least amount of fence needed. You can find your x and then plug it back into that. What would your x be? X is 600. We used this equation right here to find x. And then we would take both of those things and plug it back into your fencing equation. Or you could have just taken that 300 and plugged it in right there, because that equation right there tells you fence as well and only deals with y. But your fence needed is 2,400. That is the least amount of fencing I need in order to make this pen happen. Questions on something we did today? 0.